We're on to chapter 4 in our textbook, this is notes number 43. We're going to talk today about fractional functions. So imagine that I have a function f of x, and instead of giving you a specific numerator and denominator, I just want you to think about whatever the numerator as its own function and whatever we have as the denominator as its own function. So we have a couple things we need to think about. The first thing you need to always think about is your domain. What is that domain going to be? Remember your domain, your denominator here, your d of x. This cannot equal 0, okay? So we're going to do something so we remember not to put anything there. So we're going to put a vertical asymptote at wherever d of x is equal to 0. So that's the first thing you're going to do with your fractional function or your rational function, as we call it. The second thing we're going to think about are our horizontal asymptotes. Okay, so you've got a couple different options. If your numerator power is less than your denominator power, then you're going to put a horizontal asymptote at y equals 0. Okay? If your numerator power is equal to the denominator power, then you're going to put your horizontal asymptote at y equals a over b. And a over b are the leading coefficients to your fractional function. So if I go back and I think about this as x to the nth plus blah, 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 and this would be b x n to the something, let's call it m plus blah, blah, blah. Okay, so we could go ahead and think about a and b as our leading coefficients there. And our third case is if our numerator power is more. If it's more than the denominator power, then you have no horizontal asymptote. But what's coming next is you are going to have a slant asymptote. But that's coming. Not yet. Not today. Okay. All right. So we're thinking first about our domain. We're going to second thing we're going to do here is think about our horizontal asymptote. And our third thing we're going to think about, I know this is what you want to do, is think about your zeros. Okay. So if you have a fractional function, when is that function going to be equal to 0? Well, you're going to take, let's see, when y equals 0, or if you want to think about it, when f of x equals 0, right? When is that going to equal 0? That's what you're thinking, what does x equal, right? What does x equal? Which really means, what does our numerator equal? So what does n of x? When does that equal 0? So we're going to set that equal to 0 and we're going to solve. All right, so if you think about these three steps, you're thinking about in your fractional functions, you're thinking about your domain, your horizontal asymptote, and your zeros. I know exactly what you're thinking. Let's do a problem, Glennon. Let's get right to it. So let's go right to our problem. Let's try, we'll leave this right here so we can refer back to it. I'm going to do page 337. I'm going to think about number 7. Okay, so I've got f of x is equal to 3x squared over x squared minus 1. And I know as soon as you see that x squared minus 1, right away, you are going to think about that as the factored form. I know you guys. X plus 1, x minus 1. Okay? So the first thing we're going to think about in that problem is we're going to think about our domain. What is our domain? We're going to say x is an element of all reals, except x cannot equal plus or minus 1. We cannot have plus or minus 1 in our domain. Okay, so that's where I'm going to put my vertical asymptotes. Now I'm going to attempt to draw a graph here. It's a lost cause, but I'm going to put a vertical asymptote here at -1 and +1. Okay, I think my graphs are going to keep me from going prime time here. Okay, so there's my vertical asymptotes. And the second thing I talked about is we've got to think about our horizontal asymptotes. And we said, look at the powers, right? So if we look at our powers here, we see the numerator power and the denominator power are exactly the same. Therefore, we're going to have our horizontal asymptote is y is equal to a over b. So our horizontal asymptote is going to be at y equals a over b, so 3 over 1. Okay, so I'm going to go 1, 2, 3, and put in my horizontal asymptote. So the graph is starting to take shape. The next thing I need to think about is my zeros, right? Where are my zeros? And as I said over here, think about when does your numerator equal 0? So when is 3x squared going to equal 0? Well, x equals 0, right? So we know the graph is going to touch right here. Okay, I've got my domain, I've got my horizontal asymptotes, I've got my zeros. I have no what else to think about. What about my y-intercept? Can I think about that? Kicking it back, old school from what we did before. We're going to let x equal 0 and put that into the function. So we would have f of 0 is equal to 3 times 0 squared over 0 squared minus 1. So let's see, 0 times 0. Yeah, well, it's right there, isn't it? Kind of disappointing. So this is the point in our class where I'm not going to make you pull out a T-chart. I'm not going to torture you with it. This is the point where you're going to pull out some technology. You're going to pull out Desmos, you're going to pull out your TI-84, and you're going to go ahead and you're going to fill in the rest of the graph. And you go, oh my gosh, look at that. I knew exactly where my asymptotes were. I knew exactly where my intercept was. Okay, it's good to go. So that's a second example. And that's a good start for today. So your assignment for this one, again, all of our notes always match up with our homework assignments. So homework assignment is 73. It's going to go with that. There are lots more examples in your textbook. You can go ahead and work with those. But that's all I got for you today.